So good morning. I think everybody are in. Let us start with the class. As I already told, today's class is very important. I hope the slides are visible. Is it? Slides are visible, right? Reply me in the chat window. Okay, thank you. So 58 members are in. See, whatever I explain you today will be very helpful for your basic understanding of digital circuits. As you know, the subject is ADE, analog and digital electronics. Okay. So, like previously, when we did the introduction class, I had told you about the time, right? Analog clock time and digital clock time. So, analog clock time is not always very accurate. Like you cannot pick the time accurately, wherein digital clock time is accurate. Why it is accurate? Because it will be shown like that, 5, 10, like that, in the using the numbers. Similarly, we have multiple devices previously which were analog and now it is digital. So if you recall the cameras which were used in previous generations, it was all analog camera, right? We used to get negative and then we used to develop it. But now everything is digital. We have digital cameras. So module 2 was entirely about digital circuits. I will add up few things to that. Whatever you have learned already, it will be a bridge course for you to take up module 3. Okay. So whenever I say binary logic, it deals with binary variables. So what are those binary variables? It will be either 0 or 1. So we using 0 or 1, we will perform logic operations. Already know about this. Three basic logic operations are and, or, and not. So what is this and or not? Okay, so look here students. This is and, dot is and. If you have two inputs A and B, if you have two inputs A and B, F is equal to A dot B means A and B. So 0, 0, 0 and 0 will give you 0. If A is 0 and B is 1, A and B will give you again 0 only. If A is 1 and B is 0, then also you are getting 0 only. If A is 1, if B is 1, it is giving you 1. Now, can you tell me which mathematical operation this resembles? Please tell me in the chat window. And operation resembles with which mathematical operation? I need a reply. Ah, very good. I got multiplication. Two people, more than three people replied. I'm very happy about your replies. So it resembles multiplication operation. Similarly, we have or operation. A plus B. 0, 0 is 0, 0, 1 is 1. When A is 1, B is 0, the answer is 1. And A is 1, B is 1, the answer is 1. So this resembles which operation? Addition, correct. Okay, but the only thing is 1 plus 1 will not become 2. That much common sense we should have when we are dealing with binary logic. And similarly, not. If the input is 0, the output will be 1. If the input is 1, the output will be 0. Correct. So we know that three basic logic operations are there and or not, and binary logic variables are typically we take A, B, C or X, Y, Z as input, or any alphabet we take as input. Okay, so whenever we consider some expression, what will be there? You already know it. F of variables, a comma b comma c. That means three variable. A comma b comma c comma d, four variable. A comma b comma c comma d comma e, five variable. Like set of binary variable which acts as input will be given here. Correct. And expression, what expression will be having? It will be having various operators, variables like that. So here we have an example. F of a comma b means two variable function. So a dash dot b plus b dash. It can be anything. We have just taken example. Similarly, g of x comma y comma z, three variable function. G is a three variable function. So how to obtain g? X dot y plus z dash. Okay, so we know that and will take minimum two inputs. Three input can also be done, but minimum in general it takes two input, or will also take two inputs. So it will become binary operation, and not will become unary operation. Why unary operation? Because single operand we will be giving. Okay, so all these things you know. But what I didn't tell now, like I know, you know that if f is a n variable dependent function, how in if you write a truth table, if you write a truth table for n variable dependent function, how many rows will be there? This is the question thrown to you. If you are writing a truth table for n variable dependent function, how many rows will be there? Reply in the chat window. I repeat my question. If you are going to write the truth table for the function, Boolean function, which is having n variables, how many rows you have? Okay, if you are feeling this question as difficult, if two variables are there, how many rows will be there in truth table? Nobody is replying. Very good, 4. Similarly, 4 is there. 4 variable is there. Why 8? Is it 8? 4 variables means it is 2 power 4. Correct. 2 power 4. 2 power 4 is how much? 16. So in general, if n variables are there, for n variables, the truth table will have 2 power n. Ruchita said it. Very good. Okay, Shubha also said it. So 2 power n rows will be there. That is the basic knowledge you should have. Okay. Okay, now this is something I didn't tell you, but previous in basic electronics you might be knowing, but still I am telling once again. Whenever I say AND gate, how it will be represented? This is the symbolic representation of AND gate, and this is the symbolic representation of OR gate, and this is the symbolic representation of NOT gate. Okay. Are you clear till now whatever I told students? Please reply me. Now you know the symbol of AND gate, symbol of OR gates, and symbol of NOT gate. Yes, thank you. Thanks for the reply. Now, this is something you need to observe the next slide, which is given, like which is very important in your lab. Just give some attention to the PPT or the presentation, whatever I'm displaying in the shared screen. Okay, let me increase the, let me make it slideshow as well. Okay, so can you understand what this particular diagram is showing? Okay, so just give a thought, think about it, what exactly it is telling, and after a few seconds, I myself will tell you, and you please relate it to your understanding. Okay, this is called as timing diagram. Students, listen carefully. This is called as timing diagram. This timing diagram will show you status of the input and status of the output. So this timing diagram is for AND gate, OR gate, and NOT gate. From this point to this point, T0 to T1, it will be one state. Again, from T1 to T2, one more state. From T2 to T3, one more state. From T3 to T4, one more state. From T4 to T5, one more state, like that. So you know that in binary logic, we have only two states. What are those two states? Actually, in general, you can say it as high and low stage. But what do we call as high stage? We call high as 1. What do you call as low? You call low as 0. Okay. So here, now what is the value of A? A is 1. What is the value of B? B is 0. Okay. A is 1 and B is 0. When A is 1 and B is 0, what do you expect A and B to be? You expect A and B to be 0 only. That's what is represented here. But when A is 1 and B is 0, what do you expect A or B to be 1? That is represented here. So this level is 1 and this level is 0. And A is 0, you are having one function h which is A dash. So obviously it should become 0. So from this point to this point, one operation. For A1, B is 0. What is A and B? What is A plus B? And what is A complement? And similarly, here we have A is 0 and B is 0. So from T1 to T2, A is 0, B is 0. Obviously, A and B, you already know it should be 0. A or B should also be 0. But what about A dash? A dash will be high. Okay, similarly, it continues. I will take the last instance wherein you have A as 1 and B as 0. So A as 1, B as 0 means A and B operation will be 0. A plus B will be 1. A complement will be 0. Okay, so this is the diagram what you will write in your further. You have to understand this diagram. You better copy this diagram or uh, okay. Now, did you understand whatever I told about the timing diagram? Students, please reply me in the chat window. Anybody who didn't understand about the timing diagram. This is very much important for further modules. Very much important for further modules. Did you understand timing diagram? Okay, somebody is asking me to repeat. I'm going to repeat it. See here T0, T1, T2, T3, T4, T5, 6 says the timing of one particular signal. So if one input is high or output is high, it will be in that state from T0 to T1. Or if it is low, it will be in that state from T1 to T2. That means from this point to this point, it will be having same level of signal. That is the basic assumption. Okay. And also, there will not be any delay in the hardware. That is the basic assumption. Now, whenever you want to write timing diagram for certain Boolean operation, you will write T1, T0, T1, T2, T3, T4, T5, T6 like that. And you will write vertical lines. Okay, after writing vertical lines, how many inputs you need? Those many vertical lines. Here 6 inputs are there, so 6 lines. Here A is there. This level represents one value of A and this level represents 0 value of A. Okay, so similarly, this level represents 1 of B and this level represents 0 of B. So here A is having 1 value and B is having 0 value. And this is to indicate A and B. So if this is 1 and this is 0, A and B will be obviously 0. That's what is indicated here. If A is 1 and B is 0, G is A or B. So it will be high. So this is indicating 1 and A complement would be 0. This is indicating 0. And similarly, if you take one more operation wherein here what is the value of A? A is also 1, B is also 1. So, okay, I will come to the second operation itself. In second operation, what is happening? A is becoming from 1 to 0. It is becoming from 1 to 0. And B is continuing from 0 to 0 only. Okay. So now what happens? A and B should be 0. It is maintaining, F is maintaining 0 itself. And G is becoming 0 from 1. Why it is becoming 0 from 1? Because now both A is 0 and B is 0. A or B will be 0. That's why it is becoming 1 to 0. This point is called as transition. This point is called as transition. Why transition? Because it is changing from 1 to 0. And similarly, A dash is changing from 0 to 1 because now the value of A is 0. A dash will become 1. So there is a transition, there is a switching from 0 to 1. So wherever there is a switch from one value to another value, we call it as transitions. This word also you should remember, transition. You should remember this word, input signals, output signals, timing diagram, all those things you should remember. So if I ask you this, right, I'll give you this truth table and I'll ask you to write timing diagram for this. What you will write? You will write T naught, T1, T2, T3, four vertical lines. And there A will be 0, B will be 0, F will be 0. Next A will be 0, B will be 1 and F will be 0. Next A will be 1, B will be 0 and F will be 0. Okay. And A will be 1, B will be 1, F will be 1. That's how you can write it. Now did you understand? Timing diagram? Reply me in the chat window, students, please. Okay. Now. See, in the third module, we will be hearing repeatedly combinational logic circuit. This is the word you will hear repeatedly. So what do you mean by combinational circuit? So consider one equation. AF is equal to A dash plus BC dash plus A dash B dash. Okay. How to implement this particular equation using hardware? Okay, using equipments. You will take input C and you will give it to NOT gate. Okay, you will give it to NOT gate. And you will take input A and you are giving it to NOT gate. You are taking B, one as it is you are taking. Here you observe, and one you are giving it to NOT gate. So I want first expression to be A dash. So A dash I'm giving to this OR gate because we have OR operation here. How many inputs are given to OR gate? 3 inputs are given. One is A dash, one is BC dash, one more is A dash B dash. But here, in order to give B and C dash, I am using one more AND gate, okay, where it is inverting C and it is taking B as it is and it is converting into BC dash and giving it as one input to OR gate. And similarly, you are getting A dash, you are getting B dash, you are ANDing it, and the result you are giving to OR gate. So it is a 3 input OR gate. Okay, so in order to implement this particular circuit in reality, how many gates you need? We are in need of 1, 2, 3, 4, 5, 6 gates. 6 gates, among which OR gate is having 3 input. So these kind of circuits are called as combinational logic circuits. Okay, so combinational logic circuits are nothing but simple Boolean circuit. Okay, we have one more variety that you will learn later. Simple Boolean circuits, how to implement it practically by using the gates. Wherever AND operation is there, use AND gate. Wherever is not operation is there, use NOT gate. Wherever OR operation is there, use OR gate. Like that. This is nothing but combinational logical circuit. Okay. Did you follow what is combinational logic circuit, students? I'm expecting the reply in the chat window. Please reply me in the chat window. Okay, I got reply from Rakshita, Ruchita. Okay, Rohit Tadiga, Prerana, thank you for the reply. Now let us continue. Okay. So we will go further into this combinational logic circuit. So look at the look at the truth table here. Look at the truth table. How many inputs are there? 3 inputs are there, A, B, C. Okay. So F is one output, G is one output. Okay. If you observe, both F and G are same output it is. Okay. But here you observe, I'll make it a slide show. Here you observe, this is F is equal to A dash plus BC dash plus A dash B dash. How many terms are there? 3 terms are there. In first term, 1 literal is there. In second term, 2 literal is there. In third term, 2 literal is there. But G, though it is same as F, A dash plus BC dash, that's all. Only 2 terms and in total 3 literals. Now, I would like to ask you, okay, I'm your supervisor, I'm asking you to implement this F function. Okay, I'm asking you to implement this F function. Will you use this circuit, a dash plus bc dash plus a dash b dash circuit you will use, or you will use a dash plus bc dash? That is the question. So did you understand the question, students? Now, if I, being your supervisor, if I ask you to implement f function, you will use a dash plus bc dash plus a dash b dash or a dash plus bc dash. That is the question. Please reply me in the chat window. Okay, I got 3 replies saying G. Why G? What is the intention of using G? Why not F? The see entire module 2 is dependent on it. You should reply, otherwise your teacher is also waste and you also didn't learn anything. Number of inputs would be reduced. Simplified function. Yes, why simplified function? Less number of gates. Yes, correct. Why less number of gates? Somebody should tell it. Very good. Prashant Patel said cost effective. That is very much important for us. For us, two things is important. One is money and one is time. Cost effective, it is also called as economical. It will save money. I am building a washing machine. I want to make it a simplified function washing machine, digital washing machine. Why simplified? Because I want to sell it using a less price. Then only people will buy. That is one thing. And also, if it is washing fast, when it is wash fast, if the in the logic, if the number of gates whatever you have used is less, if the number of gates is less, it will be fast. If the number of gates is less, it will be cost effective. Two important reasons for minimization of logic function is economical reasons and to increase the speed. You should always remember this, and this will be your viva question. Okay, and this may be your interview question when you claim that you have learned ADE. You may be trying for interview like internship and all. They may ask you, why do you have to simplify the equation? So you should be knowing the reason, students. Why do you have to simplify the equation? Because you want to save time and money. That is the reason. Okay, that's why we did K-map. That's why we did Quinn-McCluskey. That's why we did Petrick's method. That's why we did map entered variable. All that circus we did only to reduce the equation. And why we are reducing the equation? Because you want to implement your equation in a economical and less time consumed way. Okay, so it's not. So whatever I Are you people following whatever I told till now? Reply me. Prerana, can you unmute yourself and tell me what did you or didn't you understand, please? So that I'll repeat.
Ma'am, your voice was not audible, ma'am.
From which point, Prerana? Uh,
Ma'am, from
like look at the slide.
ma'am, when you started,
Okay,
ma'am,
that
when
is
you
okay.
started sharing screen from that time, we didn't hear.
Okay, somebody should have told in the chat window, right? Okay, now like you understood why F is better or G is better? That you understood, right? Look at the slide what I'm sharing.
Yes, ma'am.
G is better. Why G is better? Why? Okay, I'll simply repeat whatever I covered. You can unmute yourself, Prerana. So what I'm telling is, when two functions are exhibiting same functionality, I'm going to implement the function with less number of literals and less number of Boolean operation. Why do I do that? To save money and to save time. Okay. So this is F and this is G. When you are practically implementing, obviously I will go for G because both are having same functionality. Okay. Okay. At least till now everybody understood? There is a clarity, right? There is a clarity and continuity. We just covered gates. How does it actually symbolically represented? Shubha, now everything is clear? Okay, so let us continue then. Next is Boolean algebra. Okay, so this is not there in your syllabus, but still for the basic knowledge, you need it. Whenever we use literal means single variable. Whenever you use product term, literal is connected by dot. Whenever you say sum term, literal is connected by plus. All these things you already know. I'm simply revising it. So literal means a variable or its complement. Product term means two literals connected with dot. Sum term means two literals connected by plus. Okay. So this Boolean algebra are having various properties. Okay. X plus 0 is X. Obvious, right? Addition will not make any difference. But X dot 1 is X. This is called as unit axiom. X plus 1 is always 1 because if X is 0 also it will be 1 and 1 plus 1 also 1 in Boolean algebra. And X dot 0 will be 0. Likewise, we have many rules. X plus X is X itself. Okay. X dot X is X itself. X plus X dash will be always 1. If you recall, we use this formula so many times. Wherein we use this formula so many times? While performing MEV. Okay. While performing MEV, map entered variable, we used to take common, right? So there we used X plus X dash is equal to 1. X plus X dot X dash is equal to 0. And if you take a 2 times complement of a variable, it will be variable itself. Okay, like this, you have many laws. We need not have to worry about the laws. Okay, as and when required, I will just tell you the laws. But now we are supposed to remember something. What is that? Um, okay, look here. Um, So whenever we want to simplify something, we use first approach is algebraic manipulation. If you observe here, f is x dash yz plus x dash yz dash xz. Okay, then what I am doing, I am observing here. One second. Okay, so here if you observe x dash y and x dash y is common. Like just like normal algebra, I will take x dash y as common. and z plus z dash, as you know, it will become 1. Okay, so x dash y dot 1 xz, so totally you will get this. From initially we had 3 terms, finally we are having only 2 terms. This is one way of reduction. This is one way of reduction. So we call this kind of simplification, this kind of simplification as what we call as algebraic manipulation. So I didn't teach you much of algebraic manipulation. Why? Because this is not there in syllabus, but you should be having an idea. Having what idea? K-map is not the only way. Before that, algebraic manipulation were there. But I have listed out the disadvantages that is there in your syllabus. Why don't we use algebraic manipulations? For that, disadvantages is there. That is important question for your internals. Okay, so what are the disadvantage of algebraic function? Make it a note. What is the disadvantage of algebraic function? Uh, um, Simplification. Okay, algebraic function simplification, that is there. Okay, but algebraic manipulation as it is not there. But you got an idea, right? How exactly algebraic manipulation will happen? Please reply me in the chat window. Did you get an idea? Like from the previous problem, what I showed, taking x dash y as common and making z plus z dash as 1 and converting from 3 terms to 2 terms. So you got an idea, right? How exactly the algebraic simplification will happen? Please reply me. Yeah. Okay. Thank you. So now, after algebraic manipulation, what happens? Okay, this is not required for you. Huh. You just look here. This I had already told you, and I made you to write related assignment. But once again, I am repeating. If you have a three variable input, if you have a three variable input, 0, 0, 0, like that, 2 to the power of 3 is 8. So there will be 8 rows. Min term is always represented by small m. Max term is always represented by capital M. So what is the equivalent min term for this? X dash, y dash, z dash. What is the equivalent max term for this? X plus y plus z. So this is already know, right? You already know. Just a revision. Just have some concentrate and just look and observe what exactly is min term, what exactly is max term. Okay, so now we should be aware of this sigma and pi. I have already told you, right? So many times it is already told. Sigma min terms 1, 2, 4, 6 means what? It is actually summation of min terms. First min term, second min term, plus fourth min term plus sixth min term. That's why it indicates sum of products. And similarly, pi m0357 means what? It is product of max terms, product of max terms. So if you want to convert, you observe here, students, I'll make it slideshow from current slide. You observe here, I want to convert this into product of max terms. 1, 2, 4, 6. So this indicates these min terms are 1. Okay, that indicates the other minterms are 0. So whichever the minterms are 0, those minterms will come in product of max term. So 0 is not there, so 0 will come here. 3 is not there, 3 will come here. 5 is not there, 5 will come here. 7 is not there, 7 will come here. You should be like, I can give you problem as sigma m or pi m, my wish, and you should be able to convert it to each other and you should be able to solve the problem. Okay. Okay, that's given here once more. So if the problem is 1, 2, 4, 6, it is equivalent to pi of 0, 3, 5, 7. One minterm 1 means it is a dash b dash c for the 3 input variable. Minterm 2 means a dash b c dash. Minterm 4 means a b dash c dash. Minterm 6 means a b c dash. Similarly, max term 0 means a plus b plus c. Dot max term 3 means a plus b dash plus c dash. It continues. You already know it. Okay. So here I'm showing some other 3 gates. Please make a note of it, students. Till now I had shown you and, or, and, complement, isn't it? I just showed you and, or, and not, but I'm showing you now further gates. I'm showing you now further gates. So just make a note of it. After this, I am closing the class. See, observe here. This gate is buffer. So buffer means what? Whatever you gives in, that will only comes out. There is no bubble here. For not gate, there will be bubble. Here, there is no bubble. This is just buffer. So observe here, truth table of buffer. Truth table of buffer is if x is 0, f is also 0. If x is 1, f is also 1. Similarly, NAND gate. So NAND gate, there is a bubble here. Okay, and NOR, for AND gate there is a bubble here. For OR gate there is a bubble here, that will become NOR gate. So you can guess the answer. Whatever the answer will come for AND gate, its complement would be output of NAND gate. So 0 0 is actually 0 in AND gate, so it will be complemented because of this bubble, and you will get 1. And 0 1 is 0, and it will complement, so NAND gate output is 1. 1 0 is also 0, it will be complemented, so you have 1. 1 1 is 0. And similarly xy, 0 plus 0 is 0. It is in NOR gate, there is a bubble, so it is getting complemented. And similarly 0 1 is 0 or 1 is 1, so it is getting complemented to 0. 1 plus 0 is also 1, complemented to 0. 1 plus 1 is also 1, and it is complementing 0. This is the truth table for buffer, NAND gate and NOR gate. Okay, this much information is enough for today's class. If you haven't put your attendance, please put in the chat window now. And one more thing, if you have any doubts till now, whatever the basic stuff we covered, if you have any doubts, let me know. Please let me know now itself if you have any doubts. So I pre-assume that everybody understood whatever I taught today. The important thing you have to understand is truth table of NOT gate, AND gate, OR gate, buffer, NAND gate, and NOR gate. And or buffer, not NAND, NOR. These gates truth table and its symbol. And along with that, knowledge about timing diagram. Okay. So everything is okay. I will stop the recording and I'll close the class.